Hello, I am Raghav Gupta and I am going to talk about my application Goggle Vision. It is an Android app also known as Glassware because it is developed for Google Glass. The outline for my presentation is as follows. I am going to talk about the approach, the underlying concept, and what are the previous work done in this area, what are the related apps already available, what are the hardware required to run this application, how I implemented this application, and how a user can use this glassware, what are its results, and I will also draw some conclusions based on these results. The approach is pretty simple. I am using the camera available on Google Glass and I am streaming its live feed on a single board computer. The single board computer that I am using for this purpose is pcDuino 2 board. This not only enables remote access to the camera but also allows developers to apply complex image and video processing techniques using the host processor available as a separate unit. There are quite a few applications available which follow the same approach. Some of them are Livestream, Kickflick, LiveLens. All these applications tend to provide the stream from the camera of the Google Glass either on their own website or on some social websites like Facebook. Thus, their major drawback is that they cannot provide independent feed remotely on a single board computer such as pcDuino 2 board. SpyDroid, which is a mobile app, is capable of providing remote feed of the camera to any device having a web browser, but its use being only limited to smartphones does not solve the purpose. SpyDroid uses libstreaming API which provides support for streaming camera and microphone of any Android device using RTP over UDP. The implementation and use of this application requires certain hardware. The most important of them is Google Glass. Google Glass is an optical head-mount display unit which can be put on as a simple pair of sunglasses. It comes loaded with Android 4.4 and has 640 x 360 HiMax display. It is also equipped with Wi-Fi and Bluetooth and has 2 gigs of RAM and 12 gigs of available storage. It also comes equipped with multiple sensors such as gyroscope, accelerometer and magnetometer, and it is also armed with an audio transducer. But the most important feature of Google Glass is its 5 megapixel camera, which is capable of recording video of resolutions up to 720 pixels. This camera is mounted on the bulky side of the frame, which also has other hardware accessories. The interesting feature of this camera is its position, which is right next to the eye, giving a very realistic view. I am also using pcDuino 2 board, which is a single board computer. It comes armed with 1 GHz Cortex A8 processor, 1 gigs DRAM, 4 gigs flash, which can be extended up to 32 gigabytes. It also has HDMI video output. It is compatible with Arduino headers and it has Wi-Fi module and one USB host port. The board is based on Linux 3.0 and comes pre-installed with Ubuntu 12.04. Since it is a Linux-based development board, it also provides support for languages like C, C++, Java, Android, and Python. Some external hardware accessories are also required to set up pcDuino 2 board. These accessories consist of a power adapter, a monitor with HDMI input, a set of wireless keyboard and mouse. All these external accessories can be plugged into the input ports provided on pcDuino 2 board. The image on the right shows a working setup for the pcDuino 2 single board computer. The Goggle Vision glassware is implemented keeping in mind the underlying concepts of the SpyDroid application, which is used on mobile devices for streaming the camera feed to any web browser. To achieve this task, the source code of the SpyDroid is wrapped in Google interface, which consists of live cards and immersion cards. To use the Goggle Vision, the user first needs to install the glassware file, which is a .apk file on the Google Glass using the Android Debug Bridge interface. Once installed, the glassware can be started by two ways. The first one is by selecting the broadcast card displayed on the timeline by tapping the touchpad on the Google Glass. The second is to trigger the application using specific set of sequential voice commands, which are OK Glass and Start Broadcasting. After starting the application, a web address is displayed on the bottom left corner of the screen, which the user can input into his web browser to access a web interface to provide access to the live stream. To start the live stream, the user simply needs to click on the connect button. The stream is visible in the respective box of the web page and also visible on the preview screen of the Google Glass. The user can connect and disconnect to the stream multiple times. Talking about the results, the first image depicts the use of Goggle Vision on Google Glass. The second image shows how the preview is available to the user on the Google Glass screen and how the web address is displayed on the bottom left corner of the screen. The third image shows how the simple web interface looks before starting the stream. After user clicks on the connect button, the stream starts and is visible in a box on the web page as shown in the last image. While drawing the conclusions from the use of Goggle Vision application, it is imperative to talk about the camera that is provided on the Google Glass. Apart from the excellent quality of the sensor of the camera, the main and the most intriguing feature is its realistic point of view because of its location on the Google Glass. My application Goggle Vision enables the developers to access this view using simply a HTTP address. The frames extracted from the live stream can thus be processed at any remote hardware unit using various complex image and video processing techniques. The only drawback is a minor lag observed during the transmission of the stream. This is majorly caused because of the use of Wi-Fi as the mode of communication. Apart from this minor hindrance, the Goggle Vision application works perfectly fine. This is a small demo for my application Goggle Vision. I'm going to start the application by triggering it using voice command. OK Glass, start broadcasting. So by simply using these two voice commands, I am able to trigger my application. I can now see the web address on the bottom left corner of my screen of the Google Glass, which I need to use to stream the video. Before starting the stream, as you can see here, I have connected my pcDuino 2 board with the monitor, the keyboard and the mouse using its input ports. So I have got here a wireless adapter, an HDMI cable, and also I've got a power source. I have opened the Chromium browser on my pcDuino 2 card and keyed in the web address. I have now got a web interface which is quite simple to access. The web interface provides me with the options to configure the stream, as can be seen here. The default configuration works best for this Goggle Vision application, and the user can click on connect and start the stream. So as you can see, the stream is started within the box on the web interface, and when I move my head, the stream also moves and provides the updated view. This stream can be started and disconnected multiple times by clicking on the connect and disconnect button. Thank you for watching this presentation.